Assalamu alaikum. My name is Aftab Hussain Shakib. My ID is 22408025. And today's computational intelligence presentation covers information extraction in NLP. Over the next 8 slides, we will go from the core idea of turning unstructured text into structured knowledge all the way through the four main subtasks named entity recognition, relation extraction, event extraction, and core reference resolution, and finish with three real industrial applications. So now, uh, what is it? Information extraction sits right at the intersection of natural language processing and knowledge engineering. The goal is simple to state. Take unstructured documents like news articles, resumes, or medical records and pull out the facts hiding inside them in a structured, machine readable form. Today's agenda works through that pipeline. First, the core concept and the end-to-end pipeline. Then a deep look at named entity recognition, relation, and event extraction. And finally, three industrial applications that show where I actually pays off in the real world. So here is the canonical IE pipeline. We start with raw text. Anything from a news article to resumes or an electronic health record. Step 2 is pre-processing, tokenization, part of space, tagging, and sentence splitting. Step 3 is named entity recognition, which finds the persons, organizations, and locations in the text. Step 4 relation. Step 4 builds on those entities to extract relation and events, the links between them. And step 5 writes everything into a structured knowledge base, often as RDF triples or a knowledge graph. The key takeaway from this slide is that errors propagate. If an error misses an entity, relation extraction downstream simply cannot recover it. So upstream quality matters disproportionately. Now, named entity recognition is the foundation of any IE system. The example at the top shows the task in miniatures. Take the sentence Barack Obama was born in Hawaii. Uh, and label the entity spans with their types. Barack Obama as person and Hawaii as location. Historically, the dominant approach was linear chain conditional random fields, where you engineer features like capitalization, gazetteer, lookups, and part of space. Then train a sequence labeler using the biotagging scheme. CRF model CRF models are interpretable and work well in low resource settings. Today, through the state of the art is neural. By LSTM CRF, by LSTM CRF was the first big jump, and modern systems fine-tune BART or Robert as token classifier. They learn features end-to-end from raw text and transfer beautifully across domains, but they are data hungry and harder to interpret. Once we have entities, the next question is how do they relate? Relation extraction classifies the semantic link between two identifies entities. In the example, the sentence Apple was founded by Steve Jobs in 1976. Yes, the triple Apple founded by Steve Jobs. There are three main families of approach: rule-based, Methods use handwritten patterns and dependency paths. Very precise, but they don't scale. Supervised machine learning trains classifiers like CNNs by LSTMs or BART-based taggers on level relation corpora, which gives strong accuracy but requires level data. Distant supervision is a practical middle ground. Align text with an existing knowledge base like Wikidata or Freebase to generate weak levels at scale. The level are the levels are noisy, but the approach lets you train on massive text corpora without manual annotation. Next, event extraction reference resolution. Uh, Two remaining subtasks round out the eye picture. First, co-reference resolution. Consider the sentence Marie Curie discovered radium. She won the Nobel Prize. A human reader instantly knows she refers to Marie Curie, but a machine doesn't. Co-reference resolution links different mentions, pronouns, partial names, definite descriptions to the same canonical entity. Without it, downstream reasoning loses track of who did what. Second, second event extraction. Here we look for a trigger word, usually a verb or nominalization, and then identify its structured arguments. In in Microsoft acquired GitHub for 7.5 billion in 2018. The trigger is acquired, and the arguments are Microsoft as the buyer, GitHub as the target, 7.5 billion as the price, and 2018 as the time. Together, co-reference and event extraction let us build genuinely rich, queryable knowledge representation. So now, let's ground all this in three real industrial applications. First, resume parsing. Every modern applicant's tracking system uses NER and IE to pull out skills, job titles, education, and dates from incoming resumes, automatically populating structured candidate databases. This cuts, uh, uh, this cuts manual screening time by roughly 80%. Mm, Second, medical record extraction. Hospitals and clinical research teams run eye over electronic health records to extract diagnosis, medication list, and lab values. That structured data feeds clinical decision support systems. And there is an entire subfield around HIPAA aware de-identification, so the extracted data is safe to share. Third, financial compliance monitoring. Banks and regulators extract counterparties, transaction amounts, and risk events from filling and news feeds in real time. Then, flag suspicious activity for anti-money laundering review. The same fundamental NLP stake powers all three. That's the practical value of information extraction. To wrap up, here are the five things I would like you to walk away with. Um, First, information extraction is fundamentally about turning unstructured text into structured, queryable knowledge. It's the bridge from documents to databases. Second, named entity recognition. Second, the named entity recognition is the foundation, and you should remember the trade-off. CRF models are interpretable and work in low resource settings. While neural models like BiLSTM, CRF, and BERT-based classifiers are current state of the art. Third, relation extraction classifiers classifies the semantic links between entities, and there are three main approach families: rule-based, supervised machine learning, and distant supervision. Fourth, event extraction, ev- uh, event extraction and co-reference resolution complete the picture by linking mentions to entities and structuring events with their arguments. And fifth, the industrial impact is real and measurable. Resume parsing is in HR, medical record extraction in healthcare, and compliance monitoring in finance all run on the same fundamental stack. Thank you. That brings us to the end of the presentation. Thank you for your attention.